So we're continuing in this section, and this first example asks, in what quadrant would you find the terminal side of negative 910? Right? So I don't know if you want a second to try to figure that out. I get various answers when I'm in the classroom. So if you want, I'll give you 30 seconds. Maybe I'll do it too. Hold on. Give you 30 seconds. I see we have some answers coming in already. I have a piece of paper here, but it's not hiding anything. I'll move it down. So 900 or negative 910 degrees. Negative means we're moving clockwise or we're going down. So one rotation is 360 degrees. Two rotations is negative 720 degrees. Right, so it brings us to our initial side here at negative 720 degrees. I'm going to add 90. That will bring me to a negative 810. And another 90 will bring me to negative 900. And what did I say? 910. So I got to go another 10 degrees. I think, correct me if I'm wrong, but I think negative 910 degrees looks like quadrant 2. That'd be my guess. We all agree? All right. We'll look at reference angles here. Reference angles are created by drawing a vertical line from the terminal side of theta to the x-axis. And reference angles are always acute. Right? Acute angles mean between 0 and 90 degrees. Therefore, they're never negative. So given the angle 120 degrees, if I wanted to create a reference angle, or sometimes called a reference triangle, we would draw a vertical line. Oh, this works out kind of good because we have this red line here. From the terminal side of theta, well, this is theta, so this is my terminal side of theta. I'm drawing a vertical line to my x-axis, and this creates a right triangle. Sometimes this interior angle here is called theta prime. Theta prime. And that's how you draw a reference angle or a reference triangle. So the question might be, given theta is 120 degrees, find the reference angle, or theta prime. And then your answer would be 60 degrees. Right? Because if this is 120, and to here would be 180, then the remaining space in between 120 and 180 would be 60 degrees. I got a big shadow there, so I'm trying to be careful. Let's do some examples. Hold on, I'll turn the page. So here we have 5 examples where you're given an angle and you're asked to find the reference angle. Right? In this first example, the angle given is 170 degrees. So we want to draw a line from our terminal side, down to x. So if this is 170 and this is 180, then this would have to be 10 degrees. It'd have to be 10 degrees. So I'll give you a few minutes or a minute or two to work on the 4 remaining examples, and then we'll do them together. So for these, I would suggest drawing the angle, right? You don't have to know exactly where 225 is, but you just have to know what quadrant it's in. So I drew all 4 of these. That's my estimation of where they should be. Hopefully I got the correct quadrants. The first example was 225, so that would bring me into the third quadrant rather. So if I draw a vertical line to my x-axis, I'm going to have a right triangle that looks like that. I know if this is 225 degrees and this is 180 degrees, well then this interior angle here, that's what we're looking for. We made a triangle, we're looking for that angle. Looks like that would be 45 degrees. In this case, theta prime would be 45 degrees. Right, my reference angle would be 45 degrees. In this next example, I gave you negative 70 as an angle, and we can have negative angles, but once we draw this and create a triangle, right, we can't have a negative interior angle of a triangle. Since this is a reference angle or a reference triangle, this would have to be a positive 70 degrees. Theta prime, positive 170. Because reference angles are always positive. It's an interior angle of a triangle. .305, same thing. We draw a line from the terminal side to the x-axis. We create a right triangle. We're looking for this angle inside. So if this is 305 degrees to this point, and this is 360 degrees to this point, then this angle must be 55 degrees. Theta prime is 55 degrees. And for this last example, this is 400 degrees. This is 360 degrees. I draw my vertical line. I create a right triangle. So from 360 to 400 is what, 40 degrees? So theta prime is 40 degrees. And that's how we find reference triangles. That's how we create a reference triangle. I'll read it from the textbook. A point on the terminal side of angle theta is given. Find the exact value of each of the 6 trigonometric functions of theta. So they're giving you a point. That point lies on the terminal side of theta. So let's see what this means here. This means, let's draw a big XY axis. All right, we're going to be formal about it, I guess. Given the point -4, -3, 1, 2, 3, 4, 1, 2, 3. We're given this point, and this point lies on the terminal side of theta. So it's a point on a line. So given the point -4, -3, find the 6 trig functions of theta. Well, we could create a reference triangle, right? We could draw a line here and create a right triangle. And since this is a right triangle, even though this is at -4, this distance is 4. And this is -3, but this distance is 3. But since we're in this quadrant, we're going to keep it as -4 and -3. And our hypotenuse is not given. But in this triangle, we could find this hypotenuse by using a Pythagorean theorem, right? Easy enough. Every time I keep my hand there, it's just darkness, I bet. Let's do Pythagorean theorem and try to find this remaining side, or you know this is a special triangle, right? So either you recognize it as a 3, 4, 5 triangle, or if not, we could just use Pythagorean theorem, and we could find that C is equal to 5. So now if I want to find the 6 trigonometric function values, if I want to find sine of theta, let me write them down here. So these are the 6 trigonometric function values that we're supposed to find, which is easy enough because we know sine is my opposite over my hypotenuse, cosine is my adjacent over my hypotenuse, tan is my opposite over my adjacent, and then the reciprocals, ho, ha, ao. So our reference is from this angle. This would be my opposite and my hypotenuse. So it looks like we have negative 3/5, negative 4/5. My opposite over my adjacent is negative 3 over negative 4, which is 3/4. And then we have all the reciprocals. 5, negative 5/3, negative 5/4, and positive 4/3. So that's all they're looking for. They're looking for the 6 trigonometric function values. And what you need to know also, or what you might want to know, or maybe you already know, is we have an acronym, All Students Take Calc. And what this tells us is that in the first quadrant, all the trigonometric functions are positive. The A stands for all positive. The S in the second quadrant means sine is positive, right? So that tells us that sine and its reciprocal of cosecant will both be positive in the second quadrant. If our triangle was in the second quadrant, that would be the scenario. In the third quadrant, which is where we are, right? Our triangle is in the third quadrant. That means tan is positive. Tan is positive, which also means cotan is positive. And we could check that. In our example, we see that tan is positive and cotan is positive. And all the other trigonometric function values are negative in that quadrant. And lastly, in my fourth quadrant, cosine is positive, which means also secant is going to be positive, and all the other remaining trig function values will be negative. So if you just remember that, you don't actually have to draw it, right? You could have just drawn a regular triangle. We could have drawn a triangle like this, right? And we could have done 3, 4, 5, 3, 4, 5, right? And then we could have just made a note that this triangle occurs in quadrant 3. So then when we found all the trig function values, we know that they would all be negative except for tan and cotan. It's just a shortcut or an observation. You don't have to do it using All Students Take Calc, but it's very helpful. So given 0.5, negative 5 lies on the terminal side of theta, find all 6 trigonometric function values. So you're going to want to plot that point, draw a terminal side, create a reference triangle, label all the sides, and then find the 6 trig function values. I'll give you a minute, and then we'll come back and we'll do it together. So you see I've plotted the point 5, negative 5 and that lies on the terminal side of theta. So I draw a line through it because that lies on a terminal side of an angle. So I want to create a reference triangle. So I'm going to draw a line from the terminal side of theta to the x-axis, which creates a right triangle. They want us to find all 6 trig function values. Since this is in quadrant 4, I know that cosine is going to be positive, right? Sine, cosine, and tan. I know cosine will be positive, and all my other trig functions will be negative. So I could put in my values here. I have 5 and negative 5. And now we want to use Pythagorean theorem to find the hypotenuse. So we see using Pythagorean theorem, we end up getting the square root of 50 is equal to c, and this could be broken up as 25 and 2, or 5 rad 2. Whoops. 5 rad 2. So my hypotenuse here is 5 radical 2, I believe. Note, hypotenuses are always positive. They're always positive because a hypotenuse is always the result of the square of the sides, right? The square of the legs. So if it's the result of the square of the legs of the triangle, the hypotenuse always has to be positive. So now we have all 3 sides of this triangle. All we have to do is determine our 6 trigonometric function values. So let's do that. So let's see. We need the 6 trigonometric functions. So sine is our opposite over our hypotenuse. We're looking at an angle up here. My opposite over my hypotenuse would be a negative 5 over 5 rad 2. My cosine is my adjacent over my hypotenuse, so that's going to be positive 5 over 5 rad 2. And tan is going to be my opposite over my adjacent. My opposite is negative 5, and my adjacent is positive 5. So we got 3 trigonometric function values. They could be simplified, and the denominators can be rationalized. But before I do any of those changes, I like to get all 6 trig function values in. So that way I'm not rationalizing denominators twice. So like in this example, if I take the reciprocal, this is just going to be 5 rad 2 over 5 negative. This is going to be 5 rad 2 over 5 positive. And this is going to be negative 5 over 5, the same actually. Now we could simplify it, which maybe over here it's easier to simplify. This looks like a negative 1. Those 5's cancel out. This is a radical 2. Those 5's cancel out. This is negative radical 2. So those were easy. These aren't going to be so much fun. We're going to have to, let's simplify them, and then we'll rationalize denominators. So if I'm simplifying, I'm canceling out these 5's. So I have a negative 1 over rad 2. Here I have a positive 1 over rad 2. And this is just equal to negative 1. So these 2 examples, I have to rationalize the denominator. So I have to multiply the top and the bottom by rad 2. Multiplying to rationalize the denominator. So it looks like I'm going to be left with negative rad 2 over 2, positive rad 2 over 2, and this one will stay negative 1. And those would be sine, cosine, and tangent. And over here we have our cosecant, secant, and cotangent. What do you think of that? This section continues and has some problems on quadrantal angles. Hopefully you're familiar with quadrantal angles from college algebra and trig. Quadrantal angles, if it was a classroom, I would say, what's quadrantal angles? Quadrantal angles are angles whose terminal side lies on an axis. Right? The terminal side, angles whose terminal side lies on an axis. Right? And this occurs, how often does this occur? It happens every 90 degrees. Right? You're familiar with quadrantal angles. You know, you've seen them before. Right? They're angles like 0 and 90 and 180 and 270 and 360 and 450 and 540 and 630 and 720 and 810 and 900 every 90 degrees and backwards. So like I said, 0, 90, 180, 270, 360, 50, 540, ... And negative angles as well. So you could have negative 90, negative 180, negative 270, negative 360, negative 450, ... Right? Those are your quadrantal angles. I don't have enough room here, but let's look at a unit circle. Right? We said a unit circle has a radius equal to 1. Right? The radius is equal to 1. And we've worked with angles in this section, actually. And we've discussed these right triangles, and when we discuss them, we call them opposite and adjacent and hypotenuse. But in more advanced textbooks, they're not going to refer to them as opposite, adjacent, and hypotenuse necessarily. They're going to refer to this distance as x and this distance as y, right? Horizontal is x, vertical is y, and my radius, or my hypotenuse, is now my radius. So in the past, a few minutes ago, sine theta was opposite over hypotenuse. Well, now sine theta is my opposite, which is y over r. And cosine of theta, which was adjacent over hypotenuse, is x over r. And tan, which was opposite over adjacent, opposite is y, adjacent is x, is going to be y over x. And the reciprocals are still the reciprocals. So cosecant theta, secant theta, and cotan theta will still be the reciprocals. This will be r over y, this will be r over x, and this will be x over y. So write that down and absorb it. So if we look at our trigonometric function values in terms of x, y, and r, and then you were asked to find the function value of sine of 90 degrees, well, sine of 90 degrees, we know 90 degrees is up here at 12 o'clock. Right? This is 90 degrees. I want to find sine of 90 degrees. Well, what do I know about that 90 degrees? Well, we said this is a unit circle. So my radius is equal to 1. So that means this distance is 1. So then this point would have to be 0, 1. The coordinates of that point are 0, 1. So by having the coordinates of that point and knowing that this is a unit circle, we know what x is, we know what y is, and we know what r is. So we're given all three values that we need, right? And we know sine of 90 degrees or sine of anything is y over r. So in this case, my y is 1 and my r is 1. So that means this is really 1 over 1. Sine of 90 degrees is 1. So let's look at these 1, 2, 3, 4, 5, 6 examples. And let's see if you guys could do it. I'll give you a minute. All right. I won't give you a minute. Let me start with this first one just for fun. So this first one is 180. Right, it would be there, 180. So as a point, that would be a negative 1, 0. So once again, I know my x, I know my y, and I know my r is equal to 1. Is equal to 1, right? And I know cosecant, right, is the reciprocal of sine. Sine is opposite over hypotenuse. This is hypotenuse over opposite, which is r over y. So r is my radius of 1, and y is 0. So in this case, it's undefined. The value is undefined in this case. Cosecant of 180 is undefined. So all you have to do, in short, is plot the point. There's only 4 possible places it could be. So it's either going to be negative 1, 0, 0, negative 1, 1, 0, or 0, 1. Those are only possible quadrantal angle points. And your radius is always 1, and then all you have to do is substitute it in. So I'll give you a second to do that, and then we'll work on it together, and then we'll call it a day. Let's look at 270. So 270 is over here, right? So tan is opposite over adjacent. So that would be y over x, right? At 270, my y is negative 1 and my x is 0. This looks like it's going to be undefined again. It's going to be negative 1 over 0. This one looks undefined, I believe. Cosine of negative 270, well, where would negative 270? Negative 270 is the same as 90 degrees, right? You could say it's a coterminal angle to 90 degrees, right? Because negative 270, let me lose my camera, negative 270 goes right to there. So negative 270 is up here at 0, 1. Cosine is my adjacent over my hypotenuse, which is x over r. So in this case, my x is 0 and my r is 1. So 0 divided by 1 is 0. So cosine of negative 270 is 0. Cotan, right? Cotan is a over o. It's the reciprocal of tan. My adjacent is x over y. And 360 degrees is over here. This would be 360 degrees. It would be a coterminal angle to 0. So what's my x? In this case, my x is 1 and my y is 0. So this is undefined as well. Too many undefineds in my example. Well, your answers are only going to be, the only possible answers you could have, because you're just dealing with zeros, ones, and negative ones, your answer can only be 0, 1, -1, or undefined. Those are your only possible answers. 900 degrees, where does that fall? I don't know. Let's see. Positive, so that's 720, right? 810, 900. So this is my 900. So its sine, it's opposite over hypotenuse.
0.
You scared me. Y over R. So it's 0 over 1. So it is 0. I agree. Negative 720. Negative 720 brings us right here anyway. And it's secant. Secant is R over X, or secant, let's do it. It's the reciprocal of cosine. Cosine is adjacent over hypotenuse, so it's hypotenuse over adjacent. So it's R over X. And my R is always 1, and in this case, my X is 1, so this would be 1. So we had answers of 1, 0, undefined, 0, undefined. We didn't have a -1 answer. Unless you want a -1 answer, you know, it'll come up. Cosine of 180 will give us -1. Cosine of 180. Cosine is my adjacent over hypotenuse. So that's X over R. Over here, 180. My X value is -1. My R value is 1. So -1. So that's how we find quadrantal angles. Oh, thank you. That's not necessary. I appreciate it.